Hello guys, this is Dipen Shah and welcome to my presentation, and I'm going to cover today geographical coordinate system to plane coordinate system, which is very essential for ArcGIS mapping or in engineering perspective. It is very useful to know about the coordinate system, what's happening inside the coordinate system, projection or whatever in every branches of civil engineering, like water resources, transportation engineering, or environmental engineering. You must know the coordinate system. You must have a good knowledge on coordinate system. I will try to cover the coordinate system which is used in Bangladesh, and from Bangladesh point of view or Bangladesh perspective, I will try to cover the coordinate system. Actually, what coordinate system, what projection systems are used in Bangladesh. I will try to cover this very much in this presentation. So let's get started. First of all, what is plane coordinate system? Actually, our Earth or our globe is spherical. All we know that if we want to convert this spherical surface into a plane surface, that is, and then if we represent that plane in a coordinate system, that is plane coordinate system. So when you take a plane surface from a globe or from a spherical plane, there will be some distortion. It's obvious. So you cannot fit a plane in a spherical surface. So first of all, we have to understand the basic things or basic terminology that is used in a coordinate system. Our globe is spherical, spherical in shape, but if for our simple consideration or for the simplicity purpose, we consider our globe as a ellipsoidal, which is ellipsoidal means it is in elliptic shape, or it is an imaginary surface. Let's say our globe somewhere all over the globe, the terrain is not uniform. Somewhere mountains are there, or somewhere valley is there. So if you consider a uniform spherical elliptical shape, spherical shape, then it will be treated as ellipsoid. We see in the screen that this is a circle-like globe, which is elliptical, and this is in the north direction and the south direction. These are the poles, two poles. One is north pole and another one is south pole. If you divide this ellipsoid or this sphere, then the biggest circle that in the center, it is called equator. And this is my ellipsoid surface, and if we pass a axis through the pole north to south, that is called semi-minor axis, which is the length of this semi-minor axis is smaller than the semi-major axis, which is passing through the center east to west. This is our semi-major axis. Okay, from a spherical coordinate system, we actually to find a coordinate, we use latitude or longitude. So it's a very important it is very important to know what is latitude or longitude. It is nothing but degree from the equator and from the prime meridian. So if we, let's say this is my point, I want to find out this coordinate. If this is my this plane, as you are seeing, the equator plane, if we draw a line here from this point, the angle that is created from the equator, that is called latitude. This latitude can be 0 to 90 degree, 0 to minus 90 degrees. So minus 90 degree to plus 90 degree is the latitude range. So what is longitude? Longitude is the, if total circle can be subdivided into several circles like this, which circle is the biggest circle to perpendicular to the equator, and the prime meridian is on that surface. It must be perpendicular to the equator, and the prime meridian should be in that surface. From that surface, from that prime meridian, from this surface, you have to go to this point. So you have to follow this angle. This angle is called longitude at P. After going to this point, then you are still in the equator surface. Then from the equator surface, you have to go to this point. This angle, as you are seeing my cursor, this is called latitude. So as our globe is a 3D object, so if we subdivided whole globe like this circle, it will be total 360 degree. So our longitude varies from minus 180 degree to plus 180 degree. So all over the world, any point, the ranges of longitude is minus 180 degree to plus 180 degree, and latitude is minus 90 degree to 90 degree. So this is the basic things of understanding of latitude or longitude of a spherical 3D object or our globe. I have already discussed what is latitude, longitude, or height, or ellipsoidal height. Ellipsoidal height means the imaginary ellipsoid that we consider. From that point, the distance between that point to this point, this is called ellipsoidal height. So our globe is not perfectly sphere. It is ellipsoid-like or ellipsoid-like object. So in the North Pole to South Pole, if we pass a line through the center, this is called a Semiminor Axis. This is slightly smaller in length from the Semi-Major Axis, which runs through the east from the east to west and passes through the center of the ellipsoid, and these two lines meet at the center of the globe at perpendicular, and the vertical line is Semi-Minor Axis and the horizontal line is called Semi-Major Axis, and Semi-Major Axis is represented by A, Semi-Minor Axis is B. So there is another quantity A minus B by A, which is referred as flattening. If we inverse the flattening, we can get the inverse of flattening. So when we generate or produce map in ArcGIS, we use different kind of projection system like BTM in Bangladesh, widely used, which is referred to as Bangladesh Transverse Marketer, or another coordinate system also used by BIWTA, which stands for Bangladesh Inland Water Transport Authority. They usually BUTM coordinate system, which refers Bangladesh Universal Transverse Mercator, and another and latitude longitude coordinate system is also used in some cases, but these three. And another one that is widely used in the all over the world, UTM coordinate system. Bangladesh actually located in UTM 45 north and 46 north zone. So actually these four coordinate systems are most popular coordinate system in Bangladesh. We Bangladeshi engineers are used to use this type of projection system. So there are several type of projection like conic projection, cylindrical projection, planar projection. What is projection actually? So in simple term, if we want to define the projection of a map, so our globe is spherical, right? So if we want to represent our globe in a plane surface, so you have to project the spherical plane into a plane surface. So the procedure and or how the system, how the methods you are following to do that, that is called projection. So there are different types of projection, as I mentioned earlier. There are transverse Mercator, there are universal transverse Mercator. Universal transverse Mercator is the most popular projection system, which is in short, which is called UTM coordinate system. I will discuss about UTM in later slide. See, this is my UTM zone actually. The whole spherical earth is represented in a plane sheet, and let's say our globe, you are fitting in a cylinder shaped object. Then you just cut the cylinder, then unroll the cylinder, you will get a flat surface, right? Then that flat surface you will subdivide the whole area into see minus 180 degree to plus 180 degree. That is whole spherical globe will be covered here, and up to minus 180 degree to 180 degree in UTM coordinate system 60 zones are there. See, if we consider our Bangladesh is here beside India. So see 45 and 46. So in 45 zone and 46 zone, our Bangladesh has just fallen. And see, this is our equator line, and up to minus 82, minus 84 degree, we consider the cylinder. We are not going to 90 degree to minus 90 degree, because as we go to the north direction, more distortion will occur, or in the same case will happen in south direction. So up to 84 degree to the north, and to the south is minus 80 degree have been considered for UTM coordinate system. So for northern side or southern side, there are other projection system. So what I was in Bangladesh, see Bangladesh is above the zero line. See, above the zero line. So it is located in northern side, northern 45 and 46. So it is divided by one line. See here, this one. So 45, 46. So whole Bangladesh is fall in UTM 45 northing and 46 northing. So I have already covered in the previous slide. So what is the UTM coordinate system? I will recovered. See, each zone is is from north to south. It is 10 kilometer from the equator, 10,000 kilometer actually, and In the southern part, it is also 10,000 kilometer. Total is if you consider 90 degree, but we are considering 84 degree, less than 10,000 kilometer. So this is my equator line. And see, this equator line is considered actually as 10,000 kilometers, so that for neglecting the negative value of northing. And this is my North Pole and South Pole. This is central meridian line, and this is equator line, and this is the part of globe. We have just cut the globe 6 degree and fit on the plane surface. The central meridian is assigned as 5 lakh meters easting. This is my central meridian. This is 500. See, 5 lakh, 500 kilometer. That means 5 lakh meter. We consider it for our for the simplification of coordinate system to avoid the negative value. And for UTM northing, we consider the equator. The equator is assigned as 10,000 meters for the same region. And this is azimuthal projection system. This coordinate system is not that popular in Bangladesh. This is actually another kind of projection of our globe. Azimuthal projections results from projecting a spherical surface onto a plane. It is sometimes used to show air route distances, and distances measured from the center are true, and distortion of other properties increases away from the center point. That means this center point you will get the accurate distance, or distortion is minimum. As we go away from the center, our accuracy level will be decreasing. So you have to have the clear conception about the datum or geodetic datum. So what is datum actually? Datum is a reference line from where a particular point is measured, or the height or height is measured. Let's say mean sea level is a datum, and from that mean sea level, any point on the earth, the elevation is measured from the mean sea level and the distance of that point. This vertical distance is called the elevation, or from the reference line, that means level, is called the datum. It's the datum. But what is geodetic datum? Geodetic datum, as we have shown earlier, that our globe is considered as a ellipsoid, and the semi-major axis, and semi-minor axis is A, B, and 1 by F. And to fit the whole world into a good shape, or where minimum distortion, or with higher accuracy, what value should be used for a datum, geodetic datum. These are the values for World Geodetic System 1984. This is one kind of datum, geodetic datum. So where A is this value, B is this value, and inverse flattening is this one. And there are difference datum, geodetic datum, like this is World Geodetic System 1984 WGS 84. So under this datum, we actually there are several projection coordinate system like UTM coordinate system is under WGS 84. When we produce any map in ArcGIS, the datum is, if your map projection system is in UTM coordinate, then your datum will be WGS 84. Suppose if you want to produce a map in Bangladesh transverse market route, then your datum should be average 1830. That is another kind of local datum to fit the Bangladesh very well and get accurate GPS value or the distance value in the map. So then you need the datum shift from WGS 84 to Everest 1830. See, the Bangladesh transverse market road, the semi-major axis is 637727. But in geodetic system 1984, semi-major axis and semi-minor axis are not the same. This different because the spheroid, the ellipsoid that we considered for Everest 1830 and WGS 1884 are not same. The projection parameters are for BTM is like this. And if you want to just convert to your projection system like BTM to UTM, then you need datum shifting. From BTM, if you want to go to BTM to UTM, then you have to convert your datum from Everest 1813 to WGS 84, or you can use vice versa, UTM to BTM. If you want to convert, then you have to shift your datum from WGS 84 to Everest 1830. There is another datum, spot image system. So there are 7 parameters for shifting our datum. These are rotation of x, rotation of y, rotation of z, translation of x, translation of y, translation of z, and the scale. These are called 7 parameter datum shifting. Or another one is 3 parameter shifting. The 3 parameter is same major axis, same minor axis, and the inverse flattening. So there is a popular project in in Bangladesh is FAB 24. For FAB 24, a new coordinate system was developed, but nowadays it is not used um, no longer. So for FAB 24 coordinate system that have been used in after the flood of devastating flood in 1988, the FAB project was initiated by the government of Bangladesh, and then this coordinate system has been used. This is a JMBP project, Great Coordinate System. For Jamuna Bridge project, it was used actually. Datum conversion method, this 7 parameters datum conversion method. Suppose you have WGS 84, all the parameters you have for WGS 84. Now you convert your WGS 84 to a local coordinate system, then you have to provide the proper values for rotation x, y, z, translation x, y, z, and the scale. So I think I have already discussed about this figure. So in the center, the circle, if we just subdivided our whole sphere, the center circle, the biggest circle is the equator, and the biggest circle north to south which is perpendicular to the equator is called the central meridian. And the angle from the central meridian is longitude, and angle from the equator is latitude. Latitude represents the distance north to south, and the longitude is represents the distance from east to west. I have already discussed this one, and Cartesian coordinate system. We all know what is Cartesian coordinate system. Cartesian is nothing. It's a plane coordinate system. In class 10, 9, 10 or 11 in school we have learned what is Cartesian coordinate system. You have a x-axis, you have a y-axis, and you have origin. From origin, you find it. You locate some point in the plane. You have to go to x-axis, then y-axis, and you will find the point. That is called if I simply explain the Cartesian system, that is the thing what I wanted to explain. And this is our ellipsoid. I've already explained what is semi-minor axis and semi-major axis. Let's say this is my reference ellipsoid. A is semi-major axis, B is semi-minor axis. So I think by this graphics you can understand what is latitude, longitude, and ellipsoidal height. Again, I'm playing it for you. I've already explained this in the previous slide. Geographical coordinate system actually represented by latitude and longitude. This is geographical coordinate system. And for Cartesian coordinate system, let's say x and y and z. This is my sphere. Somewhere this point I want to find out. Then it is x, y, z. By x, y, z point, we can easily find out any point in the Earth surface or anywhere. And by this geographical coordinate system, by two angle we can find any points. So I have discussed this slide, and this is the 3D, this 2D map, but it looks like 3D. So I think you have understood what is latitude and longitude and what coordinate systems are actually used in ArcGIS for mapping purpose or any other survey. For topographic survey, for feature survey, you must need the coordinate, and for mapping, it's very important to know how coordinate system works. See, I will do survey for this area in the globe, and I want to develop a new coordinate system. Then consider ellipsoid such a way that it fit here. So you can considering a new ellipsoid for your area, your coordinate system, your mapping will be more accurate. Then you need the datum shifting also if you consider a local ellipsoid. As I said earlier, cylindrical projection system is nothing but if you fit your globe into a cylinder, then just cut the cylinder, unroll the cylinder, you will get the cylindrical coordinate system. and this is another one which is second coordinate system, and this is the transverse cylindrical projection surface. See, the globe is like this, and you put your cylinder in transverse way, and this is in oblique way, and then cut your cylinder and unroll it, and you will get a surface, and the projection coordinate system will be created. And this is the last slide of my presentation, and thank you all to be patient for this lecture. And I think this coordinate system explanation will help you to understand how the coordinate system, projection system works, and how to use it. Thank you guys for your contribution in my channel. Please subscribe this channel